Dear students, in this recording, I'm going to go over progress learning quiz questions for March 2nd. Remember, I have put in an option for shuffled questions. Your question number will not look like the same as my question number. Okay, so here the question says, there are 3 children in the Macomb family. Which sample space represents the gender order male, M, or F, or female in which the children could have been born? You want to write down all the different possibilities, right? Here the word sample space means all possible outcomes. As a reminder, sample space means all possible outcomes. Okay, so this family has 3 kids. What are the possible genders? Which answer choice lists out all the possible genders. Here A says all could be male, male, and male, or 2 males and 1 female, or the first one being male, second one being female, the third one being male, or it could be the first one being male, the second one being female, or the third one being female. Seems like it is missing several of the possibilities. What if they're all female children, right? What if the first 2 kids are females and the third one is a male? What if the first and the last child are females and the middle child is a male child? Right, so seems like A is missing a lot of different possibilities. Let's look at B. So all could be male, all could be female. Yes, B does have that too. C does also, right? Then first 2 could be males, third could be female. First one could be male, second and third could be female. First could be female, last 2 ones could be males. First 2 could be females, third one could be male. See, they're missing some possibilities. Let's see. Do they have the possibility that the first and the last child could be a male and the middle one could be a female? They didn't list that out, right? Um, the rest kind of looks good, right? And female, the first and the last child could be females and the middle child could be a male. They didn't list that one out. So there are a few missing in answer choice C. Let's look at D. D seems to be missing some possibilities. Also, let's see. Okay, so D is actually missing that there might be a male first and a male last and a female in the middle. D is also not right. It doesn't list out all the possibilities. B is the only one that lists out all the possibilities of the kids without repeating. Right? So what does answer choice B say? It says the first child could be male, second be male, third also be male. Another possibility could be first child be male, second child be male, third child be female. And continue reading like that. Remember, you're looking for all possible outcomes. Okay, so in this one, what is the sample space when a coin is tossed twice? Sample space again means all possibilities. We have seen 3 diagrams in our class, right? And lists. So here they have shown you a list. What is the sample space when a coin is tossed twice? Twice means 2 times. This shows possibilities of a coin being tossed 1 time. This shows possibilities of a coin being tossed 2 times, but doesn't list out all the possibilities, like it is missing tails, tails. It is also missing heads, heads. B is not right. B is also missing a possibility, heads, tails. But A is the one that is listing out all possibilities. You might get heads and another heads, or heads and another tail, or tails and another tails, or tails, heads. This is the one that lists out all possibilities. Remember, when a coin is tossed 2 times, there are 4 outcomes. It's important to note. "15 out of the first 20 students." 15 out of 20. Students who entered the Callallen Middle School on Friday were wearing a Spirit shirt. Based on this information, if 840 students attended CMS on Friday, a total of 840 students. How many could you expect to be wearing a Spirit shirt? Again, proportional um, thinking kind of a question. You go from 20 to 840. How many times is that? It is 400. It is 42 times. Same. I'm going to do 15 42 times. And that will tell me. People go ahead, multiply 15 times 42. I got an answer that is 630. So I can say 630 students were wearing a Spirit shirt. Out of a total of 840. Okay? You set up what is given, that 15 out of 20, 15 out of 20 were wearing a Spirit shirt, then how many out of 840? X out of 840, so you do proportional reasoning. You make the fraction bigger by 42 times to get to a denominator of 840. Jax is using the spinner shown for a probability experiment. The outcome of his first 32 spins are in the table. He lands on an odd number 20 times, on an even number 12 times, out of a total of 32 spins. Based on the information in the table, in how many out of 80 spins will the spinner land on an odd number? Odd number is 20 out of 32. Right? This is odd number. This is 20 out of 32. And we can simplify this one by 4. In fact, before simplifying, let's see what the question is saying. If odd numbers are 20 out of 32 spins, then in a total of 80 spins, how many do I expect to be odd? How many do I expect to be odd? This is how we set it up. If there are 20 out of 32 odds, then how many odds out of 80? I will simplify the first fraction by 4. And that gives me 5 out of 8. And it makes my problem much easier. Then I can find for how much out of 80. Then out of 80, I can expect 50 odds. How? In my mind, I am multiplying it by 10. So I did the same thing here in the numerator. And I got 50. Then 50 times the spinner will land on an odd number if the spinner is spun 80 times. The answer in this one will be 50. not a fraction, but the answer will be just 50 times you can expect the spinner to land on an odd number. Kenya is conducting a probability experiment with one number cube with numbers 1 through 6 on each face. She rolls the number cube, records the number on the side that is face up, and repeats the process. If Kenya is to roll the cube 90 times, what is the reasonable prediction for the number of times 1 or a 6 will land face up? I know on a number cube there are 6 numbers. Landing on 1 or 6 is 2 possibilities, right? 1 or 6 are 2 out of those 6 numbers. So if Kenya wants to do the experiment 90 times, how many times will she land on a 1 or a 2? 1 or a 6? Use your proportional thinking again, and let's figure it out. From 6 to a 90, I do 15 times. Then from 2 to a missing number, I do 15 times. Then I can expect 30. That if Kenya will roll the number cube 90 times, we can expect it to roll on a number 1 or 6 facing up 30 times out of the 90. 30 times. No fraction is the answer, but we can expect 30 times that the number cube will land on either 1 or 6 facing up. The spinner shown has 7 congruent sections. 1, 2, 3, 4, 5, 6, 7. The spinner spun 210 times. What is the reasonable prediction for the number of times the spinner will land on an odd number? There are 7 sections. Odd numbers are 1, 2, 3, and 4 out of 7. So if the spinner spun a total of 210 times, how many times can expect it to land on odd numbers? Another proportional reasoning question. From 7 to 210 times 30. I will do 4 times 30. That gives me 120. So I can make a prediction. If the spinner spins 210 times, it will land on an odd number 120 times. It is a prediction. It might or might not be true. Here it says Mrs. Kirchhoff, a math teacher at Calvin Middle School, is helping plan a staff versus students head-to-head competition for a food drive at her middle school. Mrs. Kirchhoff randomly surveyed 50 students. Okay, I can safely say that the total is 50. The question tells me that, so I'm going to trust it. And asked about the type of game each one preferred for the competition. The results of the survey are shown in the table. Based on the results in the table, which statement is not true? Which statement is false? A. Student is less likely to prefer kickball than volleyball. Kickball is 12. Volleyball is 14. This is true. Students are less likely to prefer kickball, right? It is true. I'm looking for false. The student is 3 times as likely to prefer basketball as soccer. That is true. Because 3 times of 6 is 18. This is true. because the student is 3 times as likely to prefer basketball as soccer. And 3 times of soccer, 6 is 18. True. The student is more likely to prefer kickball or volleyball. We will add, right? Then basketball or soccer. Let's check this one out. So kickball or volleyball. Kickball is 12, volleyball is 14. Altogether, that is 26, whereas basketball is 18, soccer is 6, 24. So is that true? The student is more likely to prefer. Yeah, that is 26 is more, so I can say this is true. Students are more likely to prefer kickball and volleyball over basketball or soccer because 26 is more than 24. D, I can say D is false because all of them turn out to be true. The student is 2 times as likely to prefer volleyball as kickball. Oh, this is very false. Right? Volleyball is not 2 times of 12. It is not. It is a false statement. Mrs. Ross, the counselor, is helping plan a field day at her middle school and is trying to decide what yard game she buys. She randomly surveyed 80 students at lunchtime. Very safe to say that the total is 80. Um, Lunchtime and asked about the yard game each one preferred. The results of the survey are shown in the table. Based on the results in the table, which statement is true? This time we're looking for a true statement. So beanbag toss, 14 people voted for checker, 16, Connect 4, 28, Jenga, 14, tic-tac-toe, 8 people. The answer choices say A. A student is more likely to prefer tic-tac-toe or Connect 4 than checkers or Jenga. Let's try this one out. So tic-tac-toe is 8 and Connect 4 is 28. Altogether, I can say it is 36 people. Whereas checkers and Jenga, checkers is 16 people and Jenga is 14. Altogether, that is 30. So a student is more likely, right? More likely to prefer tic-tac-toe or Connect 4, that is 36, than checkers and Jenga. This is a true statement. And I was looking for a true statement. Let's look at the rest of the statements and just be sure if we pick the right answer. A student is twice as likely to prefer tic-tac-toe as checkers. Tic-tac-toe is 8 and checkers is 16. So is 8 2 times of 16? No. 8 is less than 16. It is not 2 times of 16. You see, student is less likely to prefer checkers or beanbag toss than Jenga or tic-tac-toe. Let's check this one out. Checkers and beanbag is 16 plus 14. That is 30. Versus Jenga or tic-tac-toe. So Jenga is 14 and tic-tac-toe is 8. That gives us a total of 22. A student is less likely? That is not correct. Students are more likely to prefer checkers and bean bags because the number is 30. Total load is 30. D. A student is 4 times as likely to prefer Connect 4 as Tic Tac. Connect 4 is 28. And Tic Tac Toe is 8. 8 4 times is 32, not 28. So a false statement here. Right? 4 times 8 is 32, not 28. So it's a false statement. We can finally say A is the true answer. Dean is conducting a probability experiment using a number cube with faces labeled from 1 to 6. Dean rolled the number cube 40 times and decoded the number showing on top for each roll. The table shows the results. So remember, they gave us the total over here again, and we will not ignore that. She rolls the number cube 40 times. Based on the results, what is the experimental probability that the next time Lean rolls the number cube, it will land on 1 or 6, showing on the top face? So chance of rolling a 1 is 7. Chance of rolling a 6 is 8. The word or always represents adding. If I add 7 plus 8, I get 15. Right? So if I'm looking for probability of rolling 1 or a 6 out of 40, it is 15 out of 40. Can be reduced by 5. Because otherwise our answers will not match. It's important that we reduce each and every answer. 15 divided by 5 is 3. 40 divided by 5 is 8. For this question, I do see an answer that does match my work. That's answer choice 2. Last question. Scott has a bag containing plain chocolate pieces and another bag containing peanut chocolate pieces. The bag with plain chocolate pieces contain 6 blue, 1 yellow, 3 green, and 2 red candies. The bag with peanut chocolate pieces contain 3 blue, 1 yellow, and 4 green candies. Scott will randomly select 1 candy from each bag. What is the probability that Scott will select a green candy from each bag? This question has a lot of information, and I'm going to try to write it out and make more sense out of it. So, bag 1 has 6 blue plus 1 yellow plus 3 green plus 2 red. Altogether, these are 7, 10, 12, 12 pieces. Bag 2 has 3 blue, 1 yellow, 4 green. Altogether, that is 8 pieces. So in this question, Scott will select a green candy, right? Choosing a green candy is 3 out of 12, right? 3 green out of 12. So choosing a green over here, I just did some calculation errors here. So this is 8. And so choosing a green candy from bag 2 will be 4 8s. Right? So 3 12s and 4 8s. The chance of picking a green from bag 1 is 3/12. The chance of picking a green candy from bag 2 is 4/8. Okay? But I want a combined probability. What is the probability that Scott will select a green candy from each bag? It is the combined probability. And I'm going to multiply it as a compound event. So I'll do 3/12 probability from the first bag times 4/8 probability from the second bag. And I will then multiply. 3 times 4 is 12. 12 times 8 is 96. I will reduce by 12 because the answer should always be in simplest form. Otherwise, you will not see an answer that is matching your answer right now. So 12 divided by 12 is 1. 96 divided by 12 is 8. My final answer is 1/8. Thank you so much for attending. So this was the probability quiz for March 2nd. If there are further questions, feel free to join my math building blocks and I can help you more.